For decades, we thought we had a pretty clear picture of what causes cognitive decline, but the science is just evolving at a breakneck pace, and researchers are uncovering a story that's way more complex, more interconnected, and honestly, a lot more hopeful than we ever imagined. So let's dive into this new blueprint for brain health. And that really brings us to the central question driving a whole new wave of research. For years, the focus has been on the symptoms, the telltale signs of the disease. But what if the real problem lies so much deeper? What if our entire approach needs a serious rethink? Okay, so to really get where we're headed, we first have to talk about where we've been. And that story has always revolved around two infamous proteins that have basically dominated Alzheimer's research for decades. All right, so let's meet the usual suspects, the long-standing villains of the Alzheimer's story, amyloid beta and tau. The main theory has always been that these sticky amyloid plaques build up between our brain cells, while these twisted tau tangles clog things up from the inside, and eventually, the cells just die. And look, this isn't just some abstract theory. It's a clinical reality. To get an official diagnosis of Alzheimer's, you have to find evidence of both of these protein problems in the brain. They're completely tied together. But how they're tied together? Well, that's now being seriously questioned. Right. So what if it's not just a simple case of gunk building up? A new theory is suggesting that something much more dynamic, almost like a fight, is happening inside our brain cells. This is where a new unifying theory comes in, and it basically reframes the whole problem. It's proposing that the relationship between amyloid beta and tau isn't just about accumulation. It's a direct conflict. It's a cellular turf war. And here's the kicker. It turns out both of these proteins are fighting for the exact same spot. They both want to bind to something called microtubules, which are kind of like the internal scaffolding that gives our neurons their shape and helps transport all the vital stuff around. So here's how it supposedly goes down. First, amyloid beta storms onto the scene. It then literally kicks tau off that microtubule scaffolding, stealing its spot. So this displaced, now homeless tau protein starts to misfold and clump together, and that's what forms those infamous tangles. And then the cell's whole internal structure just starts to fall apart. Now, the implication here is absolutely fascinating. It suggests that the real thing that kills the brain cell might not be the plaques or the tangles themselves, but the structural collapse of the neuron's scaffolding. This could be a huge clue as to why just clearing out the plaques hasn't been the magic bullet we all hoped for. So this brand new understanding of the mechanics, well, it's leading to some completely new strategies. Scientists are now looking past the proteins to the very instructions that run our cells in the first place. It's called epigenetic reprogramming, and the best way to think about it is like this. If your DNA is the computer's hardware, then your epigenome is the software telling that hardware what to do. This strategy doesn't change your genes, it just changes the software, which genes get switched on or off, to try and correct the faulty programming that contributes to Alzheimer's. And you can see why scientists are so excited. As one molecular biologist, Aina Belver-Sanchez, puts it, the potential here is just revolutionary. Instead of just chipping away at the symptoms like protein buildup, this goes right to the root cause, the underlying molecular machinery that's gone haywire. And, the early results are just wow. In mouse models, a compound they call FLAV27, which works epigenetically, didn't just reduce plaques and tangles. Get this, it also restored memory, improved social behavior, and repaired the function of synapses, those crucial communication points between our brain cells. But wait, because the plot thickens even more. Researchers are realizing that the brain isn't some isolated fortress. They're discovering all these surprising new pathways and connections that influence its health, sometimes starting way earlier than we ever thought. Okay, get ready for this name, the locus coeruleus, or just the blue spot. This tiny little area deep in the brainstem is turning out to be ground zero for Alzheimer's. It's the very first place that tau tangles show up, sometimes when people are only in their 30s, long before any symptoms appear. It's like our earliest warning sign. So the million-dollar question is, how do you protect this canary in the coal mine? Well, one really promising idea is vagus nerve stimulation. It's a therapy that's already used for things like epilepsy. It sends these gentle electrical pulses to the vagus nerve, which has a direct line to the locus coeruleus. The whole idea is that this could help settle the region down and boost protective brain chemicals. So, while all this high-tech research is happening, scientists are also finding clues in some, well, very low-tech habits. Which brings me to this number, 9 out of 10. Any guesses what that could be?
Yeah, that's apparently how many of us admit to picking our noses. And while, it might sound a little silly, some scientists have a pretty plausible, if still early, theory connecting this super common habit to our brain health.
Okay, so here's the theory, and this is based on mouse studies. The idea is the habit can damage that super delicate tissue inside your nose. This creates an opening for certain bacteria to travel up the olfactory nerve, which is basically a direct highway to the brain. The brain, doing its job, mounts an immune response to this invasion, and part of that defense is to lay down those amyloid beta proteins, the very same plaques we see in Alzheimer's. So, when you start putting all these different puzzle pieces together, the cellular competition, the genetic code, these unexpected environmental risks, you get a much bigger, more holistic picture of brain health. It's one where our daily choices really do have a profound impact. And what's amazing is that the changes can be ridiculously small. Data shows that just adding 11 more minutes of sleep, about 4.5 minutes of moderate exercise, and just a quarter cup of vegetables to your day is linked to a 10% lower risk of major cardiovascular events. And a healthy heart means a healthy brain. It's that simple. It's about getting all the good stuff in and all the bad stuff out. But okay, that's small changes. What happens when you go for the whole shebang, the optimal combo? Well, you get a number like this, 57%. 57%. That is the potential drop in risk for major cardiovascular events when a person combines optimal habits. This isn't just about your heart. It's about creating a resilient brain environment. It's like you're building up your brain's natural defenses, making it way less vulnerable to the kind of stress that might kick off that whole amyloid and tau cascade in the first place. And all of this really brings us to the big final question. We're moving away from just focusing on these plaques and tangles, and we're moving towards this massive, integrated view that includes our genetics, our environment, and our daily behaviors. The future of brain health, it really seems, isn't just about finding a cure, it's about building a lifelong blueprint for prevention.